Hello, today we are going to solve another probability question that involves a customer flow at a grocery store, which is represented by a Poisson process. And it says that uh, the number of customer that arrive uh, in a time interval 0 to t is equal to k is given by a formula that is e raised to minus lambda t into lambda t raised to k by k factorial, which is the standard formula of the Poisson process. And suppose we are given another information that is the probability that in 2 minutes at least one customer arrives is equal to 0.3. So we need to find lambda, and then we need to find the probability that in the 3 minutes no customer comes, and in the probability that in 10 minutes at least two customer come, and the probability that in 1 minute exactly one customer will arrive. So the first thing that we need to see is the probability, the information that we have given is of probability that in 2 minutes at least one customer arrives. Um, and we see that we cannot use the formula to compute the probability of uh, like the value of lambda using the formula that we have, because that is used to calculate the probability of the exact number of people arriving in a time interval, not at least. So we can change that as the probability of at least one customer arriving, which is could be one or more. That can be seen as probability like 1 minus probability of no customer arriving in first 2 minutes. I hope that makes sense. If that makes sense, then we can write it as like we have 1 minus p of 0 customers arriving in first 2 minutes. Then we can write it as like k, that is the number of customers arriving is 0, and the time interval is 0 to t is equal to 2. And we can write that as 0 customer arriving in first 2 minutes is equal to e raised to minus lambda t into lambda t raised to k by k factorial, like using this formula. And we have our value as 0 k, so k is 0. I hope you are able to follow on. And lambda is 2, so we have this. So this becomes, so if you anything raised to 0 is 1, and 0 factorial is also 1, so this becomes e raised to minus 2 lambda, e raised to minus 2 lambda. Yep. Which is we have that this is equal to 0.3. So finally we have e raised to minus 2 into lambda equal to 0.3, which can also be seen as like if you take log on both the sides. So like this becomes minus 2 lambda equals log this is natural log or ln. So it becomes 2 lambda into ln equal to 0.3. Uh, oh, sorry. This will be 0.7 because the probability that 0 customer arrive in it's like this is 0.3. So this term will become the probability that 0 customer arrive in time 2 minutes is 7. I hope this is clear. I had forgot to mention it earlier. Yeah. So now this is L 0.7, which would be which would make our lambda to be 0.1783. So yeah, I have like So our lambda is lambda equals to 0.1783. Now that we have the value of lambda, uh, let's move on to the next part of the question. So we have the value of lambda for the first part, and I hope it's clear until now. So the probability that in 3 minutes no customer comes. So this would be the probability that 0 customers come in 3 minutes. Oops. That would be probability. So e raised to the formula goes like e raised to minus lambda. So minus lambda, we have the value of lambda here. So that is 0.1783 into so for our situation, like let me write the values. So k is again 0 and t is 3 minutes or 3. So like this is the value we can put into our equation. So k is equal to 0, t is equal to 3, e raised to minus lambda t, that is into 3 into lambda into 0 lambda 0.1783 into t raised to k. So k is again 0 by k factorial, which is 0 factorial. Yeah. So we have this value, which is equal to which equals to so again this is lambda t raised to 0. So again the entire value becomes like 1 and 0 factorial also becomes 1. So we are left with minus 0.1783 into 3. So this is the like final value of probability, which is equal to 0.587. 0.5857, sorry. So this is the final probability that no customer comes in first 3 minutes. Moving on to the third part of the question. So we need to find that probability that at least 2 customers will arrive in 10 minutes. So we can change this as at least probability that at least 2 customers will arrive in first 10 minutes is it can be given as so it can be given as so for our case yeah. So probability at least two customers come in 10 minutes. So what would this be? So this would be probability that one customer comes in. So it would be something like 1 minus probability that one customer comes in 10 minutes and probability that minus probability that no customer, like 0 customer comes in, has come in in 10 minutes. So I hope this part is clear for you. So we are calculating the probability that like we need to calculate these two values, that probability that one customer comes in at 10 minutes and probability that zero customer comes in at 10 minutes. And this part is fairly straightforward, so I'm like going to write the answers directly. The probability that at least one customer arrives in 10 minutes, the probability that exactly one customer arrives at 10 minutes can be like calculated using this formula. And I already have the value, so that is 0.29978. And probability that zero customers, exactly zero customer come in 10 minutes is given by 0.532. Again, we have the value of lambda. If it's not clear, I'm going to explain you again. We have the value of lambda, we put it here, and then for one customer, we put the value of k as 1 and t as 10. And for 0, we put the value of k as 0. And it's just straightforward. You have to put the values in the formula and you'll get these values. So this is equal to, sorry. The probability that no customer arrives in 10 minutes is 1.68. So this will become 0.532. The probability that at least two customer come in 10 minutes is 0.532. I hope that's clear. We'll move on to the next part of the question. So probability, we need to find that probability that in 1 minute exactly one customer will arrive. So probability that in 1 minute exactly one customer will arrive. Again, it's straightforward. One customer in 1 minute. So we just need to put the values in the formula. I'll write the values that we have. So k is equal to 1, t is equal to 1. We put these values in the formula and it becomes e raised to minus 0.1783 into t, which is 1, into into lambda, which is again 0.173783 into t, which is again 1, raised to k, which is 1, and divided by k, which is again 1. I'll skip the calculations again, but the value is something equal to 14918. The probability that one customer arrives in 1 minute is 0.14918. I hope this was clear to you, and that's it for today. If you like the video, please comment and tell me, and stay tuned for more. Thank you.